Hello everybody, hello, my name is Lara, secondary science teacher, fully qualified, experienced. You are the Science Alliance, welcome! It is Theatre of Science, Home Ed, Lesson 3. A little shout out, thank you so much to all the people who are supporting me with actual money so that instead of being a school teacher I can just do all my lessons for free, all the printouts for free if you go to my Facebook page. If you would like to join those people, because this is almost a job, but the more people that support the more of a job it becomes. I'll tell you how to do that at the end of the show. So let's just do it. Let's do fossils, right. Next week, we are doing an entire lesson on ammonites because they're very useful. But today we're setting the scene. We're doing what are fossils, how are they formed? Now, when you say fossil, you tend to think of something that is made of stone. That is not wrong, but there's all different kinds of fossils. So if you've brought a piece of fruit or veg with you, just have a look at it. I asked you a question before this show started. I showed you a screen which said that you have a sandwich. You want to eat it later, so for safekeeping, so no one steals it, you bury it in the garden. We've all been there. You come back a month later and it's gone. Why has it gone? Now, there's no comments on this YouTube video, but I imagine you're probably saying things like it would have rotted or animals would have eaten it. Maybe you use the word like decay, decompose. All correct, excellent, yes. When we say rot or decompose, what we really mean is the teeny little creatures have eaten the thing, like bacteria, fungi, yeah, maybe worms as well. So I'd like you to have a look at your, and they are like us, they're living things. So they need oxygen to breathe, they need, or to, do their version of breathing, they need water, and if they're warm, they're more active as well, okay? So I'd like you to have a look at your thing that was living before it got picked for your pleasure. How can you keep this thing fresh for as long as possible? How can you stop it decaying for as long as possible? How can you slow down the decaying process? So there's lots of bacteria all around us. What are you going to do to your carrot or whatever it is to keep it fresh? Okay? 10 seconds, as many different things as you can. I don't know how many times I've done my carrot TikTok. Okay, because I'm a psychic and I've done this lesson twice already, I know that a lot of you have said, get it cold, freeze it. Very well done. Yeah, if we froze this carrot for 1 million years and then defrosted it, technically it would be a fossil. The cutoff for fossils is about 10,000 years. The proper definition of a fossil is, it's like, a fossil is any evidence that something has lived long ago, all right? And if it's like a 5,000-year-old bone, scientists wouldn't call that a fossil, but anything older than 10,000 years, that's a fossil. So weirdly, a carrot that has defrosted 1 million years later, even though it looks just like a carrot, I mean the cells would be a bit damaged through the freezing process, but that would be a carrot, that would be a fossil. It doesn't need to be made from stone. And this is actually happening over in Russia. The huge amounts of ice that have been frozen for years and years and years are melting because the earth is getting warmer, and we're finding like defrosting mammoths and they look just the same. We're extracting their DNA. Scientists are going to try and clone mammoths. So they're just a defrosted mammoth, but it's a fossil. Bit weird. The other way you might have said is maybe you could like put this in an airtight box or cover it in cling film or wax wrap or something. Yeah. You could do that to stop oxygen getting to it so that the little creatures that want to eat it, they haven't got any oxygen, they can't decay it as fast. What's a natural way of doing that? What would be nature's way of wrapping something up so that no oxygen could get it? My favourite film, even though it's all wrong. Yeah, stuff can get coated in amber. So in Jurassic Park, there's that brilliant Mr. DNA video where he says, insects fly onto the branch of the tree and get stuck in the sap. That's not true. The sap is the liquid stuff in the middle of the tree. But there is sticky stuff on the outside of conifer trees. It's called like resin. And it's true that insects could get stuck in it. And sometimes creatures even bigger than insects. I'll show you. If you don't like spiders, you should look away now, because I'm going to show you a beautiful, possibly slightly creepy picture of a scorpion that was trapped in amber for years and years and years. You ready? Ready? Look away right now. Check out this guy. Look, so a Mexican farmer found this. It just looks absolutely perfect, doesn't it? Now, resin, once it's sort of dried and solidified for millions of years, then it turns into amber, and amber is slightly acidic. So this scorpion isn't exactly the same as it was when it got coated in this sticky resin of a tree, but it's pretty close, isn't it? I mean, for studying, that is just unbelievable. So yeah, a Mexican farmer uncovered this stone, presumably got a right shock as well. So well done if you said that you could wrap it up. Yes, so those are both fossils, even though you've actually got the thing sort of as well as you can possibly get it. The other kind of fossil, which is the sort of fossil that we're going to try and make, is a trace fossil. So this is where my whodunit comes in as well. A trace fossil is a sign that a living thing has existed, but it's not the actual thing. So the classic example is your footprints, your dinosaur footprints. It's not actually a bit of a dinosaur. It's not what we call a body fossil, but it's definitely evidence that a living thing existed. So we call it a trace fossil. So the theatre of science favourite is fossilised poo. A coprolite is a trace fossil. It's not actually a bit of the animal, but it's definitely evidence that a living thing existed. So poo that sinks into mud. Maybe it's like a certain kind of swampy mud like we had here in York, where there isn't very much oxygen and it manages to stay in one place and turn into stone. That would be a trace fossil. Burrowing creatures. Anyway, I'm not going to spoil it. I'm going to show you this. Another beautiful coloured in black and white printed sheet from Theatre of Science headquarters. I'm doing a little Cretaceous whodunit. So there is a T-Rex here, which is dead. Oh. And what I'd like you to do is, I'm going to give you some clues of, there are traces of animals all over this scene. So imagine that you're there. What would you look at? Where would you go exploring to try and work out what killed this T-Rex? I'll give you some clues and see if you can piece it together. And all these clues are based on real trace fossils that have been found. I did this in the live lessons and with the comments on Facebook a couple of days ago, and I was getting them to tell me what the traces were. It didn't really work because they got it too fast, so I'm quite glad that I'm in control here and I can just eke them out to you. So maybe you're saying footprints. Are there any dinosaur footprints around that could give us a clue as to who killed this T-Rex? Well, there are some footprints, but they are T-Rex footprints. So is that a clue or not? Leave it up to you. There is a burrow in the mud under the tree belonging to Oryctodromeus, which is the only burrowing dinosaur that we know of. But we know of that because we found a trace fossil of its burrow. It's obviously burrow itself, not a body fossil, not a bit of that dinosaur, but definitely evidence that existed. In the T-Rex's stomach is a young hadrosaur. So that's a bit weird, isn't it? Because they have found hadrosaur bones that look like they've been sort of damaged by acid. So it was the acid from the stomach of the T-Rex. So it's a bit weird that, but I reckon because it was damaged by acid from the T-Rex's stomach, that dinosaur fossil would also count as a trace fossil for a T-Rex. See what I mean? There are no tail dragging marks. So this was interesting. The American Museum of Natural History used to have a massive T-Rex skeleton with its tail on the ground, but then we realised that we've never found any footprints with this dragging tail pattern, which you would expect, and also didn't really make sense, like it wouldn't have been very well balanced, so they had to change the skeleton. But I thought that was interesting that even a trace, like not finding a trace fossil, can also tell scientists information about dinosaurs. Alright, I'll go a bit faster now. Are you getting it yet? There are unknown dinosaur feathers in amber in this tree. That is true. We don't know which dinosaur feathers they are, but they're absolutely gorgeous. You should look them up. They're almost perfectly preserved. Yeah, there's poo. There's a well, it's not a coprolite yet because this is the Cretaceous period, but there's a T-Rex poo over there. The best thing I found out this week is that I think most of us knew that poo could get fossilised. It's a beautiful fact. But did you know that when animals wee, they obviously, if they wee into like soft mud, they splash a pattern in the mud, don't they? Like if they weed up against that tree, there might be like some indentation. Yeah, urine splashes, they turn into fossils. They're called, so a fossilised poo is a coprolite. A fossilised, I'm calling it a wee splash, is a urolite. Just the best thing I've ever heard. We don't know which urolite belongs to which creature, so there isn't like a dinosaur wee splash fossil. But it's only a matter of time, people. And the last one, the one that everyone asked for straight away and got it, which annoyed me. There are teeth marks in the dinosaur leg, that belonged to T-Rex. What? Yes, it was. Well, we've got to be careful here. They have found a T-Rex bone, a few, that have T-Rex teeth marks in it. They know they're T-Rex teeth marks because it was the end of the Cretaceous period, and the only thing big enough to bite into a T-Rex's leg is another T-Rex. What they don't know actually is whether the T-Rex just came across the dead T-Rex and had a little munch, or whether it actually caught another T-Rex. We can't work that out. We think, because it's biting the leg, that it probably came across it, because the leg of a T-Rex didn't have a lot of meat on it, so if you bothered to kill a T-Rex, you probably wouldn't eat the leg, you'd eat all the other bit. Anyway, right, so well, quick quiz then, if you haven't spotted it already, another 10 seconds, which one of these fossils would not count as a trace fossil? One of these traces of animal that I've mentioned, you wouldn't call it in a few million years' time when we find it. You wouldn't call it a trace fossil. The urine splash, the teeth marks in the leg, footprints in the mud. Well, obviously the lack of something isn't a fossil, but that would still be a trace fossil. The contents of an animal's stomach, a burrow, what I said, dinosaur feathers in the amber, T-Rex poo. Which one isn't a trace fossil? Lack of comments must be really annoying some of you. I'm quite getting into just being able to totally control this and not having a series of like jokes about poo scrolling along the screen. The answer is, well done if you got it, unknown dinosaur feathers trapped in amber. The dinosaur feathers, that's an actual part of the dinosaur. So that's not a trace fossil, that would be what you call a body fossil. It's a bit of its body. All right, oh my goodness. I'm gonna get sued again, every time. Right, I get these images from Vecteezy. If you ever need any images, thoroughly recommend Vecteezy. They're great. I really hope they don't look through any of my old videos, because I've definitely never forgotten to say that. Thanks, Vecteezy.com. Right, yeah, let's make a trace fossil. So, if you've got a mug or a bowl or something like that with you, and some flour, then put the flour in the mug or the bowl, and add a little drop of water. Just a little drop, just little. Okay, we're basically just going to make rubbish Play-Doh. Just making Play-Doh out of flour and water. Don't get trapped in a cycle where you add too much water, so you've got to add more flour. There's a lot of people been doing that recently. I've seen the photo. It's not good. Flour is for eating. So I've got a bowl with some flour in. I'm just going to add a drop of water. This is already quite a good model for how trace fossils form. If you think about footprints, so the last couple of lessons we've been looking at weathering and erosion, right? So that basically just means when teeny tiny little bits of rock called sediment fall off a big rock. There's all kinds of different ways. You can watch the videos, they're on YouTube. But if there's a rock and tiny little bits of rock fall off that rock, then they are called sediment, and they get carried down rivers, and that's what you get sand. Sand is just sediment that's about 2 millimeters big. Pebbles are also sediment. They're just big bits of rock that have fallen off rock. So what kind of sediment, very big or very small, is best for trace fossils? Well, you know this already, really, don't you? If you've ever walked on a beach, if you've walked on a pebble beach, you probably notice you don't really leave any footprints. The pebbles are too big. There's too much space between them. They don't mould to your foot. If you walk on sand, you do get footprints. And if you walk on the very smallest pieces of sediment that you can get, like mud, mud is just really, really teeny tiny little bits of rock that have fallen off. You leave beautiful footprints. So we're using flour, which has obviously got it's very, very, very small particles, isn't it? Very small bit of sediment. And then, of course, yeah, in real life, the sediment, the mud, the bits of rock will mix with water to form mud. So there you go. Pretty good model for mud we've got here. It's just middle-class human mud. Right, I'm giving it a little knead. You don't want it to be too sticky. If you are commenting on my Facebook page, then I'm going to give you a little fossil quiz in a bit, and then I'll go on my Facebook page and see how many of you have said hello. Right. Now, warning, this is not Instagram. We could get a toy dinosaur, couldn't we, and push it into the Play-Doh, but would that actually teach us anything? Well, possibly. It's not what we're doing. Shush, it's not what we're doing. We're just going to have fun and fiddle and learn, okay? So I've got a carrot, so I'm going to mould my Play-Doh roughly into the shape of a carrot and see what happens. Because this is just a point that I want to make, okay? No, So push your food thing. So we'll say this is mud. Push your food thing into your mud and pull it out again. What does it look like? Whoa. Well, there's a little bit of detail there, but it's not great. Now, that is realistic, okay? That's a good model. It's so rare that you find, say, dinosaur bones that are all connected together. Overwhelmingly, even if scientists find a complete dinosaur skeleton, it's actually just a pile of dinosaur bones and you've got to work it out. The odds of a fossil being produced that look amazing without a bit of human tampering are pretty slim. Anyway, we'll say that this is a footprint now. If you want to stick some food in and take it out again, we'll say this is a footprint. How does that footprint become a fossil? Well, it doesn't most of the time, right? If you've ever been to the beach, the tide comes in and out, your footprints just get washed away. So you've got to get a bit lucky. Let's say that this is a swamp that our dinosaur, or carrot, I'm getting a bit confused. Let's say that our footprint has been made in a swamp. So it's pushed down into the soft mud, the things come away again, and then the soft mud has dried in the sun, all right? Then what happens is you kind of got a mould, haven't you? Like if you let this dry, it would go nice and hard. And then if other sediment is blown, say from the wind, we looked at that last week, into the footprint, and then, you know, water seeps in and then it forms a fossil. It's basically like if you've ever done that lovely activity where you get plaster of Paris and you push a dinosaur toy into, I don't know, do you use Play-Doh or something, or clay? I'm not assuming we've got all this stuff. Who has plaster of Paris? Not me. So what I'm doing is I'm layering flour into my footprint, because this is kind of what would happen. Sediment would layer up and up and up into the footprint. You're doing this as well. I can't believe how messy this lesson is. I'm so sorry. Slowly grown ups watching. Right, let's pat it down a bit. I'm not going to pour water in because my Play-Doh's not dry. It's just going to make a big soupy mess. But I've now got a footprint with some sediment in it, which is reasonably accurate. Now, when we think about fossilised footprints, we think of like an above view like this, don't we? We can find footprints like that, but you can also find footprints from a different perspective. If you've got your spoon, you can have a go at cutting this in half. If you've ever been to Scarborough, if you ever go to Scarborough, look up a fantastic company called Hidden Horizons. They run the fossil shop there, but Will, the owner, he does dinosaur footprint tours of Scarborough, and he will take you to the cliffs and he'll show you dinosaur footprints, and they don't look like what you'd imagine. So if I've cut this in half and I'm just going to pull it to the side, will show you the cliffs in Scarborough where they just look like normal layered cliffs, you know, like sediment that's piled up and up and over time. But every so often, you just see a little dip in the sediment. And Will, because he's got the knowledge, he knows that that's a dinosaur footprint, but it's where the dinosaur footprint's been essentially sort of sheared in half when the cliff has got to the water and the water's eroded the cliff away. You can just see where the footprints were like that, where the dinosaur dented the soil. I don't know, just very pleasing. Right, so that's a trace fossil. So water would mix with this sediment, eventually you'd get mud, okay? So it'd just be like a different kind of sediment, so you'd be able to see it. But the main kind of fossil is the kind of fossil that you think of. The fossil that like turns things to stone. How does that happen? Honestly, I can't work out a model for it. It's called per-mineralization. I'll write it down, because if you like doing the GCSE questions at the end, then you will need to remember this for the GCSE. Not remember, understand. But I think it'll help me to write it down, actually. So, per-mineralization, I just like saying the word. Makes me sound like a paleontologist. Per-mineral, that's a clue. Ization. How that happens is, well, it's quite similar to the trace footprint, so, but something has to die and then sink into mud. So I'll put living thing, could be anything, could be a tree. Oh, fossilised trees are beautiful. Living thing sinks into the mud, just like our footprint. But it stays there because it's dead now. Living thing sinks into mud, and then it gets buried in sediment. But I can feel that a lot of you are just playing with Play-Doh now. That's fine. Buried in sediment. So living thing dies, sinks into mud, gets buried in sediment. Are we all okay with that word? Just gets covered slowly over time in little tiny bits of stone, like sand or whatever. And then what happens, this is very important, this comes up all the time, is the soft body parts. What happens to them? You remember the word? Soft body tissue, I'll call it. It rots away. Well done, I heard you. Yeah, this is why we don't get fossils of very, 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 very early life on Earth, because it was all a soft body. This is why you don't find fossilised carrots, because every single bit of this carrot is very edible, isn't it, to bacteria or fungi or worms or whatever. So it's very, very difficult for scientists to study soft-bodied creatures from long ago, because we just don't have any traces of them, because they're far, far more likely to decay. So what happens when a stone fossil is made is the living thing sinks into the mud, it gets buried in sediment, and then the soft body tissue rots away. And then what happens is, well, the hard bits are left. I didn't want to make this many stages, but the hard bits are left, just in case you hadn't worked with that. Like the bone. And bone is actually quite porous. Bone's got a lot of holes in it. So what happens is, water is not pure water. It's got loads of minerals dissolved in it. Even the water that you drink at home has got like fluoride, or water might have silica in it, or calcium or whatever. So eventually water gets into the holes in the bones and things. And the water evaporates, but it leaves the minerals behind. Is that okay? Water seeps into the holes in the pores, in the hard bits, and then eventually the water evaporates, dries up, but the minerals get left behind. So a lot of stone fossils, it's where minerals have come in and sort of eventually the actual living bone bits have been replaced by minerals. I'll write that down, so that's our last stage. But yeah, the minerals have come from water. Hard bits left, minerals, replace, it's mainly bone, isn't it? I'll put minerals replace bones. There. I used to think that, when I was really little, I used to think, oh my goodness, this is actually a living thing, like I'm holding a thing that lived millions of years ago. And then I learned about fossils and I was like, oh no, there's absolutely no trace of living thing left in here and it's all the minerals. It's quite often a bit of both. There might be some bits of like cell wall in here that actually, not in here, but in most fossils that actually did live. Right. Is that okay? Yes, we've discussed why we don't usually get fossilised carrots. Yeah, I'm going to give you the sheet. The sheet. And then after that, we'll do the GCSE questions. Yeah, I'm quite pleased with the sheet. I've just given you lots of examples of things that may or may not be fossils, and you have to tell me which one's a fossil and which one isn't. Some of the information I only said right at the beginning of the lesson, which was a long time ago, quite fast. So, but I have tried to make it so that this sheet has some on it that are obvious and some of it that isn't obvious. The idea is to get you to think. The idea is not for you to be right all the time. The idea really is for you to practice being wrong sometimes and know that that doesn't mean that you're a foolish person. It's okay to be wrong. In fact, it's a sign you're learning. Right, lecture over. Could you please, there's 9 different examples here, could you say whether each example is a fossil or not? And explain your answer. Explaining your answer is the important bit. Okay, people in the comments last week were just shouting, yes, no, yes, no, yes, yes, no, no. Shh. Tell me why or why not. So a 20,000-year-old shark's tooth, is that a fossil or not? Can you remember how old I said that fossils needed to be? It's 10,000 years. A 1,000,000-year-old piece of sandstone, is that a fossil? Pebbles found in a dinosaur's stomach, which it used to digest food, is that a fossil? A particle of fat produced by a microbe, fossil or not? A real fossil that's been pushed into wet cement to leave an imprint, is that a fossil? A 40,000-year-old foal frozen in ice, true story. 4,000-year-old mammoth bones, are they fossil or not? 10,000-year-old worm trails, fossil or not? And a living goblin shark, is that a fossil or is it not a fossil? Right, I am going to have a look and see if anyone is talking to me on Facebook. While you crack on with that. comments. Oh, hello, herrings. Oh, herrings. Yeah, someone said when we were doing this lesson the other day that the fish in my crime scene looked a bit suspicious, and I said, oh, they're red herrings. Red herrings. Because a red herring is like, yeah, something that puts you off the trail, but isn't a clue. Okay. Eating it keeps it fresh. Nice! Why didn't I think of eating it? Yes, Oscar, Leon and Yumi. Oh, I'm glad you like optimism. Hello, Kay. Hello. Fellas, oh, well done. Yeah, Oscar, Leon and Yumi have been all over this. Ruben and Kai. Ruben and Kai wanted to let you know that we are currently reading Lightning Mary, all about Mary Anning. Oh, yes. Someone asked if we could do a story time about Mary Anning in the fossils lesson, but I've already done a fossils show quite early on in lockdown, and I did do a story time about Mary Anning for that. I got horribly carried away because I found out loads about her and wanted to put it all in, so I think it's a little slow, but it is there on YouTube. Right, Ruben and Colin. Oh, hello, Emily and Christina. Hi. And Felix and Henry. Fabulous. And, oh no, Sebas, you're living in a plague house. Oh, brilliant. Oh, but you're learning about prehistoric seas. Okay, that's good news and bad news. Are you learning about prehistoric seas? Oh, right, okay. So the pebbles in the dinosaur's stomach. I was thinking of a plesiosaur, actually. There's a plesiosaur in the Rotunda Museum in Scarborough, which Will from Hidden Horizons arranged, actually, and dug up. But yeah, they found pebbles in that plesiosaur's stomach. Prehistoric seas, what a great topic. All right, should we go through the answers then? Another comment from Emily and Christina. Oh, all right, Tasman. Shark. Yes. Well done. Oh, yay. I've got a picture of Emily and Christina answering questions. It's very cool that we can do that. Okay, here we are. So, yes, well done. You are quite correct. A 20,000-year-old shark's tooth. Yes, it is a fossil. It looks exactly the same as when it fell out, although actually a lot of the bone has been replaced by minerals. So the only way to tell the difference between a modern shark's tooth and a fossilised one is the weight, generally. The fossilised one weighs more. But yeah, well done. That's a fossil. A 1 million-year-old piece of sandstone. That is not a fossil. Why not? Well, it's not evidence that a thing was living. I'll put not living, okay, but that's shorthand. It's not evidence that anything has been alive. There might well be fossils inside the sandstone, but it's not in itself evidence of a living thing. Because you get stone on Mercury, don't you? And as far as we know, there's no life on Mercury. Pebbles in the plesiosaur's stomach. Well, it's a tricky one, that, isn't it? But yes, it is a fossil. You call them, they're called gastroliths. Sorry, I'm blocking the board, I know. Gastroliths. And yeah, if you could prove that they had been inside a dinosaur's stomach, then they would definitely be a very good trace fossil. So we know that plesiosaur in Scarborough used to eat stones in order to grind up its food and digest its food, just like chickens do. They're pretty good. Oh, this one's amazing, this particle of fat produced by a microbe. In fact, I might flip you round. It's probably useful for people to be able to see me if I'm talking. Yeah, and again, most of these are true stories that I found out about and thought were amazing, so I wanted an excuse to tell you about them. Yeah, this particle of fat is what we call a chemical fossil, actually. So I should have said it's a microbe. A microbe is a living thing. It was actually algae. This tiny little piece of algae, millions and millions, it might even have been billions of years ago, very, very early life form. You know how, well, it produced little particles of fat, and you know how golden syrup is thicker or thinner if you heat it up. It was the same with this microbe's fat particles, so they can tell, looking at the kind of fat that it produced, whether the climate was hot or whether the climate was cold. So it's actually a really good way of getting evidence for what the weather was like, what the climate was like millions if not billions of years ago, from particles of fat. Yeah, that's called a chemical fossil. I mean, I suppose you could call it a trace fossil because it's a trace that a living thing existed, but it's so small, it's literally a particle. It's called a chemical fossil. So yes, that is. A real fossil pushed into wet cement to leave an imprint. Well, it's definitely evidence that a living thing existed, isn't it? But it's too young, so that would not be a fossil. Obviously the fossil itself is a fossil, but the mark that it's made on the piece of cement, it wouldn't be old enough. It'd just be like a few seconds old, wouldn't it? So no. A 40,000-year-old foal frozen in ice. Well, it's older than 10,000 years old, so yeah. And it's definitely evidence that something has existed, so yeah, that is a fossil. This is a true thing. This might make you sad. They found a fossil in the ice in Russia that I told you about. This foal had thawed out, and it was only a few weeks old, I think, when it died. And they've actually extracted liquid blood from it, and they're going to clone it. I'm just going to let you decide whether that's fine or not. But it is a fossil. 4,000-year-old mammoth bones. Well done if you spotted that they're too young. It needs to be 10,000 years old to be a fossil. So no, last mammoths only died out about 4,000 years ago. 10,000-year-old worm trails. Yeah, they're just about old enough, aren't they? They're borderline, but that would be a good trace fossil. So yes, that is. And a living goblin shark. No, because the shark itself, that actual shark, is not 10,000 years old. I don't know whether a living thing lived to be 10,000 years old, whether we would call it a fossil or not. I'm guessing not. But anyway, goblin sharks are quite often called living fossils because they haven't really changed since the late Cretaceous period. So this thing's great, etc. grandparents looked pretty much exactly the same as this goblin shark. This is just working for it, you know? It's natural selection, isn't it? Sometimes evolution doesn't change a thing. If a goblin shark can exist and survive, why change? And it's also what you call an evolutionary dead end. So goblin sharks haven't changed and evolved, so there's like different kinds of goblin shark. It's only got like one branch on its family tree. So a living goblin shark, you could call it, it's often called a living fossil for those reasons, it being an evolutionary dead end and it being the same, but it's not an actual fossil. No. Right, well done if you got those. That was actually pretty good summary questions for the end of the lesson, but I know you love your GCSE questions. So do I. I've got some really tough ones for you. So I'll tell you how I'm managing to do these shows for free, and then we'll have a look at the GCSE questions and the summary questions as well. See how much you've understood, see if I can catch you out. But yes, I said at the beginning that I can only do these lessons for free. We are reaching the stage of my life where I would have to go back to school teaching, which I like school teaching, but I kind of prefer this. So enough people are supporting me that it's looking like this is a job. But if you would like to go to my Ko-fi page and give me a small amount per month, there's enough people doing it that it can be a small amount, and I can even send you nice things. So if you look for Ko-fi Theatre of Science, then you get to my page. There's like different tiers. If you would like some badges with Wormy on, our Theatre of Science mascot. Then you can pay me more if you like. You pay me as much as you like. But anyway, the things that you get to say thank you are, I will send you these rainbow glasses with an explanation that I've written for how they work, because stuff's not fun unless you know how it works. Oh, they're so good. I'm going to show you them. They make you see rainbows. I know that most of you have got them already, but there's never a bad time, is there? Look. Ooh, the whole world. Just because everywhere there's light, it splits white light into rainbows. It's very nice. And the other thing is, I will send you Theatre of Science magazine. Every couple of months. I'm a bit behind. This is the latest issue on pirates. I write it and my graphic designer husband graphically designs it. I'm really proud of it. It takes me ages, but it's so fun. It's like writing all my supporters' letters. So this one's got it's the sort of the science of pirates. So it's got a comic in it about, are there any good pirates? Like, what's the best way to save the whales? You decide. It's got I'll send you a free piece of string so that you can make some knots at the end. Barnaby, if you're watching, yours is coming very soon. It's got like the science of, would a pirate actually wear a wooden leg? Why? Why not? Why do pirates speak like that? Or do they? That was my accent. They don't, so I'm just going to stop. But anyway, thank you very much to everyone who's receiving Theatre of Science magazine. So appreciated. I just love this job. Right, let's do the GCSE questions. Here we go. So there's most of the questions that I show you are IGCSE questions, because that is the one that home editors will probably do. But there's no rock cycle or fossils on the home ed syllabuses, or the IGCSE syllabi. So these are from AQA, actually, triple science. So if you did science at school, GCSE, you'd probably end up answering something like this. First of all, for your summary questions, can you give 2 examples of a trace fossil? And can you explain why a mammoth trapped in ice is a fossil, but a 300,000-year-old stone isn't? If you downloaded the free printouts from my Facebook group for this lesson, you have got something slightly different. Can you answer my stone question? I said spear, but I'll talk about why that was a bit confusing after this. And also, question 3, can you have a go at GCSE question 3? But I've given you some words to help you out. Can you use the words sediment, covered, decay, minerals, and replace for question 3? And your GCSE questions, why are there so few fossils of very early life forms? It's a real GCSE question, for 1 mark. Is it because they were eaten by predators? Is it because fossils only last a few million years? They become extinct very fast, or they had soft bodies? Question 2, explain why fossils of dinosaurs are often incomplete. So why, when you find a dinosaur fossil, are there bits missing, basically? 3 marks, 3 reasons why bits of dinosaur fossil might go missing. And question 3, the image shows a fossil of a giant platypus. Explain how it may have formed. So the important thing here is it's like a skeleton made of stone fossil. It's not a trace fossil. So how do fossils that look like skeletons made of stone, how do they form? I think these are really tricky. Obviously, if you were actually doing it for GCSE, we'd have done a lot more revision and practice questions, but this is kind of just for fun. It's okay, I'm still here, I'm just very unusually being quiet so that you can concentrate. Oh, hi Ramin, it was you, of course it was. Ramin's answering my questions. Oh, and thanks for sharing this show. I think these are hard. I'm going to give you 1 more minute. Oh, sorry, Susie, I did go through that fast. It was 10,000 years old, yeah. Yeah, if something's over 10,000 years old, then it's considered a fossil. Wow, Emily, well done. It's amazing. Ah, Christina, that's great. Yes, well done, Ramin, you're doing well. Oh, hello, Susie Bell. Oh, hello. Yeah, splendid. Okay, let's go through these answers. She says, I'm going to have to pull up the mark scheme for this. That's like the official answers that the GCSEs give you, because if I make it up, I'll end up saying something slightly wrong. Okay, question 1. Why were there so few fossils of early life forms? Well, a lot of things do get eaten by predators, so don't become fossils, but that's not specific to the very early times, is it? Like, things always get eaten by predators, so it's not that one. We'll look at next week what can damage fossils, like earthquakes and stuff, but the answer was they had soft bodies. So well done if you said 1D. Oh, question 2. Well, I think the one that I would have got is that the soft parts decay. So the reason, I think the trickiest thing about this was understanding the question. Explain why fossils of dinosaurs are incomplete. That's a hard question, but yeah, one of the reasons why when you find a fossilized dinosaur, it's not all there, is because the soft parts have like rotted away, decayed, decomposed, or whatever. So you don't find dinosaur hearts, do you? So that was 1 mark. Soft body tissue decays. The second mark is some bits might have been eaten or moved by animals. Again, this is really just for fun. I didn't teach you this. I would have done if you were going to be answering GCSE questions on it. Bits, although this is quite good revision, isn't it? Bits might have been eaten or moved by other animals. A lot of you probably said that when you were answering the sandwich question at the beginning. And the last one which is just so obvious, I don't think I would have said it, is that it might have been damaged or eroded if you came to last week's lesson. Damaged, eroded. That plesiosaur they found in Scarborough, it hasn't got a head because they reckon a glacier just sliced it off, so that kind of thing. Or changed my pressure, we'll look at next week how like pressure affects, a week after, how pressure affects fossils. But yeah, any kind of damage. Well done if you got that. Oh, I thought that was really hard. And question 3, speaking of hard, how does this form? Oh, what are you going to say to get marks? Well, the first one is that the thing has to get covered in sediment. It gets covered in sediment, or you could have had sinks into mud. Or soft ground or whatever. So if you said anything about it sinking into mud and getting covered up, that's only 1 mark, slightly annoyingly. The second mark comes from, again, the soft bits decaying. I might not have said that. But that's why the fossil ends up looking like this, is because the soft parts are decayed. That's why we don't have the skin. And for the third mark, it was minerals enter bones. So well done if you mentioned minerals at all. Minerals enter bones. Or bones are replaced by minerals. If you've written minerals and bones, then very well done indeed. I thought they were very tough. Examples of a trace fossil. I'll move that to one side. Well, we had footprints, didn't we? A trace, so a sign that an animal has been there without it actually being the animal. It's too high up. How many trace fossils can you think of? Footprints, they're the classic. Poo, obviously. I'll put coprolite. Let's do it properly. Coprolite means fossilised poo. And I'm going to write urolite now, my new favourite thing. If I was answering a GCSE question, I probably wouldn't, because they're very uncommon, but come on. It's just such a great word. What's the other one? Like scratch marks, I suppose? On bones, or bite marks, or burrows. That's a good one, isn't it? There we go. What else? That's all I can think of anyway. Explain why a mammoth trapped in ice is a fossil, but a 300,000-year-old stone isn't. Well, the answer to that one is that a fossil has to be evidence of a living thing. Evidence of life. So a 300,000-year-old stone, it's old enough to be a fossil, but it's just a stone, so it's not evidence that life has existed. So it's not a fossil. But a mammoth trapped in ice, albeit it had to be old enough, but that would be a fossil. Okay, you lot, is that... Goodness me, my writing is getting worse and not better. I hope you've got that. Of course, it's staying on this YouTube page, isn't it? So you can always have a look back later if you'd like to hear my slightly rough and ready explanations. Yes, for question 2, until this lesson, the other days, I had why is a mammoth a fossil, but a spear isn't a fossil, a 300,000-year-old spear. And then I got myself confused and thought, oh, but wait, a spear is definitely evidence that a human has existed, and humans are living things, so wouldn't a spear be a trace fossil? And I had to look it up, but I'm kind of embarrassed I had to look it up, but there's no embarrassment. Now we know. A spear is an artifact. Stuff that humans have made, so I guess signs that humans have existed, that have been made by humans, they are artifacts. So archaeologists study artifacts, right? Like your spears, brooches or whatever. And paleontologists study fossils. So now I understand why my architect friend got really annoyed when I kept asking her about dinosaurs, because archaeologists don't study fossils. Who knew? That's a paleontologist's job. So yeah, that's why a spear, we got a bit confused, but a spear isn't a trace fossil. You would call it an artifact. My brain is a little bit bigger and more exercised than it was 2 days ago. That's why I love doing these lessons. Right, I think that's everything. Oh, the other thing I kind of wanted to drop in is that, because some people were confused and said, well, how does poo end up being fossilised if all the soft bits decay away. Soft bits don't always decay, but you have to get really, really, really lucky. So in York, we had very boggy ground. Just the right kind of ground that didn't have a lot of oxygen in it. So microbes couldn't really exist there and decay things. So this is why York is very famous for Vikings, because we found loads of awesome Viking stuff that just didn't decay. We've got a Viking cap in our museum that is like silk that's been beautifully sewn together, and you can still see all the little strands of silk that someone in 800 and something would have weaved together, because it just happened to get trapped in ground where it didn't decay. So I guess that's when we've also found a massive coprolite in York. Come to York. We've got all the best stuff. And yeah, that's why. Right, I think that's it. I think that's all the questions answered. Shall I have... So that is the end of the lesson. Thank you so much for coming. I will see you next week. If you want, like the YouTube ones, then I'll just be here, same time, 10:30 on a Thursday, to talk about ammonites. Why are they useful? All you need for that lesson is a piece of A4 paper and some scissors and a pen. Piece of A4 paper, scissors and a pen. We'll look at how the earth moves around. Why am I looking on my computer again? Oh yeah, to see if any of you have commented before I go. So I can say bye to you. Yeah, I think that's it. I haven't put an invite up on my Facebook page yet for what show we're doing on Saturday, but it is Burns Night coming up soon, so I think we're going to do the science of sheep, like Lego story time about sheep, because of the haggis. That's okay, isn't it? People aren't going to get upset about me talking about sheep. It'll be mainly just sheep. Obviously, we'll have to talk about haggis as well. It might freak some of you out. I'm sorry about that. Oh, hello. Is this... Wait, what? Facebook just gets more and more confusing. Let's have a look. Yes, you're free to go, unless you're waiting for me to discover your comment. Oh, bye! Bye, Ramin. Oh, brilliant! Oh, this is good. This is what I want. A whole answer from Emily that I can read and talk about. Amazing. The platypus would have been compressed by rocks. Oh, yeah. That's a tricky one. The platypus would have been compressed by rocks and mud. Mud is good. Well, that is right. This is why if you ever do GCSE, we'll do loads of practice questions, because it's just about knowing what they want as well. Yeah, this is how sedimentary rocks form, which we will look at later, is layers of sediment. You're absolutely right. If a platypus just got trapped in mud and left there with no pressure on it, it would not become a fossil. You're absolutely right. To make something into stone, layers of sediment do have to be compressed, squished by the weight of the sediment above. You have to have a lot of pressure to turn it into stone. But no, that wasn't the answer at all. They didn't mention pressure at all, did they? They just said that it had to be, if you'd said instead of compressed by mud, covered in mud, then that would have been 1 mark. Explain how it may have formed. Yeah, I guess talking about compressed sediment is how the rock formed, but not enough about how the fossil formed. But I'm glad you said that, because I love reading like GCSE answers that you've done, because I kind of cheat. I always just go to the answer. It doesn't tell you anything. Lily got all the fossil questions right. Yes, Lily. Oh, no way, it's your first... Oh, no, Squeaky. It's your first day of science lesson. Oh, Lily, that's amazing. I hope you're still here. Very well done if you're still here, because I've been chatting for a while now. Oh, that's so nice. Okay, brilliant. Well, thank you for those comments. Okay, I will see you next week, everybody, for ammonites. Bye. Thank you so much for your support. Bye.